Today's seminar is going to focus on angle relationships, and the standards or I can statements that we'll be focusing on are: I can identify complementary, supplementary, vertical, adjacent, and congruent angles, and I can find measures of complementary, supplementary, vertical, and adjacent angles. So just doing two different things here today. We are identifying as well as finding different measures using algebra. So at this time, if you could pause the video and write the title in your notebook as well as the standards, then we can get started. Okay, so this seminar is going to be done in two parts. The first part, we're going to look at more definitions, so we're going to have two foldables for that. And one's going to look at complementary, supplementary, adjacent, linear pair, and vertical angles. And the second one is going to look at corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. So those will be the first two foldables we'll look at here in this first video. And then in the second video, or part two, we'll be looking at the same types of angles but using algebra to find the angle measures. So that's what's going to be happening. So the first foldable I'd like you to have out is the one that focuses on corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. So first, what we're going to do is look at some definitions. So the first one we'll look at is corresponding angles. Alright, so corresponding angles say that two angles that lie on the same side of the transversal in corresponding positions. So let's go ahead and identify those. And what I'm going to do is use markers to coordinate colors so we know which angles are corresponding. And the first set that we'll have that's corresponding. So if we look at this definition again, two angles that lie on the same side of the transversal in corresponding positions. So same side of the transversal, which I should label first. This line L that's cutting through, this is known as a transversal. It cuts two parallel lines. So that is a transversal. So the first two angles I want to look at that follow this rule are 1 and 5. So those angles are congruent. 3 and 7 are congruent because they also meet that definition. Same side and in corresponding positions. Then 2 and 6 are also congruent, also corresponding angles. And then 4 and 8. I'm not going to circle those just so that we know that relationship there. So what I'm going to do quick then is, using notation that's commonly used in geometry, I'm going to write which angles are congruent to one another. So, like I said, angle 1 is congruent, and the congruent symbol is the little tilde type mark with an equal sign under it. And we said angle 1 is congruent to angle 5. They're corresponding angles. They would have the same measurement. Then we said 2 and 6 are also congruent or corresponding. 3 and 7, angle 3 is congruent to angle 7. That means they have the same measure. And angle 4 is congruent to angle 8. So all of the angles that we have circled in here and that have corresponding colors, those would all be known as corresponding angles. And that's two angles that lie on the same side of the transversal in corresponding positions. And we have identified all of those. Moving on then, we'll look at alternate interior angles, so the second one here. And what alternate interior angles are, it says, is interior angles that lie on opposite sides of the transversal. Remember, L is our transversal here, and we're looking at the interior angles here. So 3, 4, 5, and 6 are our interior angles. And since they're alternate, that means they're going to be on opposite sides. So in this case, angle 3 and angle 6 would be alternate interior angles, as well as angle 5 and angle 4. Those would be our alternate interior angles. So then let's go ahead and show that these are congruent. So angle, and that little symbol I put in front symbolizes angle. So angle 3 is congruent to angle 6. They would have the same measurement. And angle 4 is congruent to angle 5. So a little bit different notation here in geometry. So like I said, the angle symbol is this little L looking thing in front. Congruent is the tilde with the equal sign. So those would be the different types of notation that you'll have to know. This down here also, this 2 lines here between the M and the N, that tells us that line M is parallel to line N. And then, like I said, if we ever have a line cutting 2 parallel lines, that's called a transversal, which I labeled up in corresponding angles. So this covers alternate interior angles. Again, those are interior angles that lie on opposite sides of the transversal. Then, following suit, we would have alternate exterior angles. So you can probably kind of guess that these are going to be angles on opposite sides that are on the outside of the transversal. And our definition says here, exterior angles that lie on opposite sides of the transversal. So we're looking at exterior now. So 1, 2, 7, and 8 are what we're looking at here. So if we're labeling these, remember alternate opposite sides of the transversal and exterior. So 1 is going to be congruent to 8. Those would be equal. And 7 would be congruent to 2. And that's really the long and short of alternate exterior angles. The only other thing I would like to do is use our notation here to signify that these are congruent. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. That's alternate exterior angles. So exterior angles that lie on opposite sides of the transversal. Make sure you get that copied down. And last but not least, we have same side interior angles. And what that means is that 2 angles that are on the same side of the transversal and are on the interior of or between the 2 parallel lines. So we're looking at interior here, but now we're looking at the same side. And there's something special about these, which I'll point out here in a second. So angle 3 is Angle 3 and 5 are same side interior angles, and angle 4 and 6 are also same side interior angles. And what's special about these is that when these 2 angles are added together, they add up to 180 degrees. So if you're ever solving an equation algebraically and you're looking at same side interior angles, then you know that an angle plus the other angle will be 180 degrees. So let's go ahead and write that down. So what this is saying is angle 3 plus angle 5 is equal to 180 degrees. Those 2 angles added together add up to 180 degrees because you have an acute and a obtuse angle. When you put those together, they would form 180 degrees. And you have angle 4 plus angle 6, and that's equal to 180 degrees. So 2 different cases here where you would have same side interior angles adding up to 180 degrees. So make sure you have all of those written down. And we're going to apply these a little bit here. So we're going to open all these up just so that we can refer back. And we're going to answer these questions over here on the right-hand side. So let's work through these together. And we're going to have to apply some of these definitions. Now, when you're dealing with geometry, it's important to know your definitions because it's a very definition-heavy subject. You have to know what definitions are and how they apply to different situations. If you don't, you'll probably be a little bit lost. So start to kind of internalize some of these ideas so that they get easier as you move along. So it says here, use the figure above to answer the following questions. So we know that line M is parallel to line N, and that this line L here, remember this is our transversal. That is known as a transversal. So which two lines are parallel here? Well, let's use our notation that we have. We know that M is parallel to N. Kind of looks like MLLN, but this symbol means the lines are parallel. Which line is the transversal? Well, that's the one that's cutting the two parallel lines, so that's line L, and they have it in cursive. So we'll write it in cursive as well. All right, so we want all angles now that are congruent to angle 1. So we're going to have to think about our ideas here. Angle 1. And we have to think about the ones that are going to have the same measurement. In this case, the angles that have the same measurement to angle 1 are going to be angle 3, angle 6, which is a vertical angle, which we'll get to here in a little bit, but that's known as a vertical angle, and angle 8, which would be an alternate exterior angle. Okay, then let's name all the angles that are congruent to angle 2, and those angles would be angle 4. Since this transversal cuts them at the same angle, these are going to be the same measurement. The next one that would be congruent is angle 5. That's a vertical angle, which we'll talk about here in a little bit in our next foldable. And angle 7, which is an alternate interior angle. And those have the same measurement. They're congruent to each other. And then it says on number 5, name 3 pairs of supplementary angles. And if we recall, which we haven't, this is on our other foldable, and we'll get to that. Supplementary angles add up to 180 degrees. So they make a straight line. So there's multiple pairs here, but we'll just identify a few. So angle 1 and angle 2 would be supplementary angles. 1 and 2 are supplementary because these two angles together would add up to 180 degrees. Another set would be angle 5 and angle 6. There also would form a line. This angle and this angle added together make this straight line, so that's 180 degrees. And angle 4 and 8 would also be known as supplementary angles. So this angle, angle 4, and this angle, which is angle 8, those added together are 180 degrees, which is a supplementary angle. All right, moving into some relationships then down here on number 6, and you're going to have to refer to some of our definitions here. So it says, what relationship exists among angle 1 and angle 8? So let's go back to up here, 1 and 8. Well, that kind of reminds me of our alternate exterior angles. Kind of looks the same here as 1 and 8. They're both on the outside, so that's exterior. They're on opposite sides, so that's alternate, making this alternate exterior angles. Between 5 and 7, those angles would be known as corresponding angles because it says two angles that lie on the same side of the transversal in corresponding positions. They're both on the, we'll call it the right-hand side of the transversal, and they're in the same spot. They're both underneath. So those are corresponding angles. Write that down. What I'd like you to do is try 8 and 9. So pause the video and see if you can identify those, and then I'll write them down here in a minute. So give those a shot. Alright, you should have done both 8 and 9. So angle 6 and angle 7 would be known as same side interior angles. And 2 and 7, so 2 and 7, those would be alternate interior angles. And as you can see, 2 and 7, they're both on the inside, they're on opposite sides, which fits the alternate interior angles definition. Now applying a little bit of math to these ones here, down 10 through 15. We'll do 3 together and I'll have you try 3 on yourself, or by yourself I should say, not on yourself, you can't put an angle on yourself. So it says here in number 10, if measure of angle 1 is 72 degrees, so 1 is 72 degrees, what is the measure of angle 5? Well, these are supplementary angles. They add up to 180 degrees. So 1 and 5, I would need to do 180 minus 72 in order to find that other angle, and I would get 108 degrees here. Number 11 says if measure of angle 2 is 105 degrees, what is the measure of angle 7? So 2 is 105 degrees. What's measure of angle 7? Well, what I'm noticing right away is that those are alternate interior angles. So that means that they're congruent to one another. That means they'd have the same measurement. So this has to be 105 degrees. 12 says if measure of angle 4 is 102 degrees, what is the measure of angle 5? So if 4 is 102 degrees, what's the measure of angle 5? Well, what I'm noticing is that those are alternate exterior angles. That means that they're congruent, so that means they have the same measurement, so that means it's 102 degrees. So like I said, this is real heavy in looking at your definition and examples like you have on the left-hand side here. Without looking at these, you're probably going to have a little bit of trouble right away. So go ahead and try 13 through 15 on your own, and come back in about a minute when you're finished with those, or however long it takes you, doesn't matter, and I will give you the answers and explanation of them. Alright, welcome back. 13 says if measure of angle 8 is 76 degrees, so measure of angle 8 is 76 degrees, what's the measure of angle 6? Well, that looks like corresponding angles to me. So they have the same measurement, they're in the same spot, same side of the transversal. It must mean it is 76 degrees. 14 says if measure of angle 6 is 74 degrees, what is the measure of angle 4? So 6 is here, 74 degrees. What is the measure of angle 4? So this one's a little bit trickier because you're still making a straight line. You still have an obtuse angle here in 4 and an acute angle here in 6. Those two added together, those are technically supplementary angles, so they add up to 180 degrees. So if 6 is 74 degrees, we know that supplementary is 180 degrees, so we have to subtract 74 from 180. That means we would get 106 degrees, because 74 and 106 would add up to 180. And last but not least, 15 says, if measure of angle 2 is 112 degrees, what's the measure of angle 3? Those are same side interior angles. We know that those add up to 180 degrees. So we would just need to do 180 minus 112, and that would give us 68 degrees. So this is our first foldable, and this will come in handy when you come to problems that involve algebra or just identifying different types of angles. So this is the first foldable for today. We're going to move on to the second one here. So a few more definitions that we need and a little bit of algebra work as well. So you can go ahead and put this one in your notebook. And we'll start on the next one here. So we're going to look at complementary, supplementary, which we already talked about a little bit, adjacent, a linear pair, and vertical angles, which I did discuss a little bit as well. So let's look at complementary first. We'll go through definitions and then do the work on the right-hand side. So complementary says, let me zoom in here a bit, says two or more angles are complementary if the sum of their measures is 90 degrees. So complementary is 90 degrees, measure of angle 1 plus measure of angle 2 is 90 degrees, gives us a nice right angle. That's complementary. Let's go ahead and copy that down. Supplementary, which we talked about, is two or more angles are supplementary if the sum of their measure is 180 degrees. So in this case, we have measure of angle 3 plus measure of angle 4, gives us 180 degrees, gives us a nice straight line. So that's supplementary. Sometimes it's easy to mix those two up, but just remember complementary is 90, supplementary is 180. Next is adjacent angles, and what adjacent angles are two angles that share a common vertex, so a point at which they meet, and a side, but have no common interior points. So all that means is that the two angles are right next to each other. So that's adjacent angles. A linear pair, which is our next one here, says that two adjacent angles are a linear pair if their non-common sides are opposite rays. So that's kind of a mouthful, but really what that means is that two angles that follow this definition here, it means that they're always supplementary. They'll form a line. They're a linear pair. They make a line. Linear. Not linear, linear. So linear pairs are always supplementary or add up to 180 degrees. And last but not least, my favorite kind of angles are vertical angles. And what vertical angles are two angles are vertical angles if their sides form two pairs of opposite rays. So opposite rays would be these guys here pointing in different directions, and there's two pairs of them. And opposite angles and vertical angles are always congruent. So what that means, it's just the opposite angles means that they're across from each other. So we have two pairs of them here. And they're always congruent. They're equal to one another. That will be important to remember when we're setting up algebraic equations in order to solve. So those are your definitions of complementary, supplementary, adjacent, linear pair, and vertical. So let's apply this to a couple algebraic situations now, and we'll start with complementary. Now remember, complementary adds to 90 degrees. So that should be good. So it says here, find the measure of angle ABC and measure of angle CBD. So we're given two expressions here, 11x minus 2 and 5x minus 4. And we know that those two angles together add up to 90 degrees. So what we're going to have to do is say 11x minus 2 plus 5x minus 4 equals 90. We're going to have to combine like terms and do what looks like a two-step equation here. Zoom in a bit so we can see. So I'm going to combine like terms first. 11x and 5x are going to give me 16x, and negative 2 minus 4 would be a negative 6. So there's all of your integer operations again. Can't forget about those. Equal to 90. And then what we do, we have a two-step equation. We're going to add 6 to both sides. And we'd have 16x equals 96. We would divide by 16, and get x equals 6. So we know that the value of x is 6, but we want the measure of these angles. So we're going to have to substitute 6 back in for x in order to figure out what the measure of these angles are. So I'm just going to do this in my head here. So 11 times 6 is 66, minus 2 is 64. So this angle is 64 degrees. And if I do that again here, 5 times 6 is 30, minus 4 is 26. So that angle is 26 degrees. And a perfect way to check this is to say, oh, 64 plus 26, that should give me 90. Well, 60 plus 20 is 80. 4 plus 6 is 10. That's 90 degrees. So this was what I was talking about when we have algebra when we use algebra in order to solve for different angles. So that's a complementary angle. Let's now look at a supplementary angle. So we're doing the same thing, except this time it adds up to 180. So same idea here, measure of angle ABC and measure of angle CBD. So we would have 8x plus 9 plus 6x plus 17 equals 180. I'm going to combine like terms first. 8x and 6x is 14x. 9 and 17 would be 26. Going to subtract 26 from both sides. And if I did that, I would get 154, I believe. Just going to double check. Yep. So 154 equals 14x divided by 14. Divide by 14. Going through that a little quick because we've spent a lot of time doing that. And we would get x equal to 11. Now if we plug this value of x back into these angles, let's see what we get. And this should add up to 180. So 8 times 11 would be 88. Plus 9 more would be 97. And then if I do 6 times 11, which is 66, plus 17 more would be 83 degrees. So 97 plus 83 should give me 180. Well, 90 plus 80 would be 170, plus another 10 is 180. So we got her on that one. Now example 3 is going to involve the rest of our definitions here. So I'm just going to zoom out a bit in order to be able to see all of it. So it says, use the diagram to determine whether the angles are adjacent, vertical, a linear pair, or none of the above. Some of these can be multiple. So it says here, angle 1 and angle 2. We have to look at our definitions here. And what I am immediately drawn to is adjacent angle. So two angles that share a common vertex, so they share this point, but have, that share a common vertex and side, so this and this, but have no common interior points. So they don't share anything inside. So I would call this one an adjacent angle. And adjacent means right next to. So if they're right next to each other, they're going to be adjacent. Angle 4 and 5. This one is a double here. So these are going to be both adjacent and they're a linear pair. And they're a linear pair because they would form a straight line. So they're supplementary. Remember, they're always supplementary. 4 plus 5 would be 180, makes them a linear pair. 7 and 9 would be the same thing. They're next to each other, so they're adjacent. That's the best way to remember adjacent. And they would form a line. Angle 7 plus angle 9 would make 180 degrees, hence a line, so a linear pair. Try D and E on your own real quick, and then we'll check them in a second here. So you should have checked these by now. So angle 6 and angle 9. Well, those are opposite of each other. So that means that these are vertical angles. Just write vertical. And angle 2 and angle 6. Well, those don't have any relationship at all because they wouldn't form a 90-degree angle together. They wouldn't form a 180-degree angle together. They're not right next to each other because they share this side. They wouldn't form a 180-degree line, so they're not forming that. They're not vertical because they're not opposite of each other like 6 and 9, 7 or 8. Those are only vertical angles here. So there is no relationship here. None, we'll just put. So that's your second set of definitions for this seminar. You'll have to use these when we do part 2 that focuses on more of the algebra type problems like these ones up here that we worked on. So you'll have to identify the type of angle in that seminar as well as find the different measures of them. So stay tuned and you can start the second video if you have completed everything in this foldable as well as everything in the first foldable that we worked with, which was this one. Make sure that both of these get into your notebook so you can reference them whenever need be. See you in part 2.